A persistent combinatorial testing usability challenge has been the definition and enforcement of constraints among test factor values. This example is a simple illustration. Here we need configurations using Windows and Linux operating systems with 3 browsers to test 3 applications. In this test design, the 9 configurations cover all pairs of factor values. The problem is that the Linux Internet Explorer configuration is invalid. It is not supported and cannot be tested. What can we do to fix the plan? If we skip the test case, there are 2 valid interactions that will not be covered: Linux with App 1 and Internet Explorer with App 1. The situation gets even messier when there are more test factors and more complicated constraints. Research progress in this area has enabled designs to conform to constraints. Often, they are specified by logical statements. This is an example of an operating system browser configuration constraint. There are different needs for constraints. We just saw a configuration constraint. Input values can have a similar need. We can have 3 valid factor values for a date, month, day, and year, but together they're invalid because the day does not agree with the month. Constraints are also needed to include valid combinations that might not be covered otherwise. Typically, testers need to verify classes of expected results. Constraints can steer the design to cover the classes. Embedded functions represent dependent factor values as functions in a general-purpose programming language, PHP. A function's arguments are the test factors which determine the dependent factor's values. In the browser example, the fbrowser function is listed as a browser value. The function's argument is the operating system value, Windows or Linux, which determines the browser values. The fbrowser function returns a list of allowed browser values for each operating system. Let's see how that works. The text in the yellow box is a test case generation request. We have names for the factors on 3 lines at the top. Their values appear below on separate lines in the same order. This set of values for the factors is called a block. In this block, the values for the operating system and the application are fixed. The browser values are represented by the fbrowser function. It is evaluated to determine the fixed browser values for each operating system value. Then the original block shown here is replaced by 1 or more blocks having fixed values only. In this example, there are 2 fixed values blocks, one for Windows and one for Linux. Now the request is in fixed values form. All combinations of values in each block are allowed. The union of all the block's combinations are allowed in the test design. The generator uses these combinations of values to construct test cases conforming to the constraints. We just copy the request and paste it into the request form. Here is the request form. We paste in the request and click on the Submit button. The result is 9 test configurations. There are 21 pairwise combinations. All but one is covered. It's easy to see the missing combination is the invalid Linux Internet Explorer pair.